Hi, we will do problems in electrostatics. While doing the problems, we will do the theory. For every problem, there is a formula. That formula we will discuss, then we'll go to the problem. Okay. First problem. When two objects are rubbed with each other, approximately a charge of 50 nanocoulomb can be produced in each object. Calculate the number of electrons that must be transferred to produce this charge. Total charge in a given body is general formula Q is equal to Ne. Your aim is to calculate N. So N is equal to Q by E. Q is the total charge. Given 50 nanocoulomb, 50 into 10 power minus 9 by E is 1.6 10 power minus 19. 50 by 1.6 is simplified. 10 power minus 9 plus 19 is 10 power 10. This is 31.25 into 10 power 10 electrons. So number of electrons for a body which is charged of 50 nanocoulomb is 31.25 into 10 power 10 electrons. Okay, this is the first problem. Second one, the total number of electrons in the human body is typically in the order of 10 power 28. Suppose due to some reason you and your friend lost 1% of this number of electrons. Calculate the electrostatic force between you and your friend separated by a distance of 1 meter. Compare this with your own weight. Assume mass of each person is 60 kilograms and use point charge approximation. You and your friend lost 1% of the total charge. Generally, the Coulomb's inverse square law for electrostatic force. K Q1 Q2 by R square, where this K is 1 by 4 pi epsilon naught. Epsilon naught is a constant. 8.854 into 10 power minus 12 constant value. You substitute and then calculate the value of K, that is 9 into 10 power 9. 1% of charge Q is equal to 1 by 100. What is the charge given here? 10 power 28 number of electrons. 10 power 28. Charge of an electron is 1.6 10 power minus 19. That is 1% of Q is equal to 10. This 2 will go to numerator as 10 power minus 21. 10 power 28 minus 21 is 10 power 7. 1.6 10 power 7 coulombs. So substitute this value here. Q1, Q2, both are 1.6 into 10 power 7. So I can write Fe is equal to K 9 into 10 power 9. Q1, Q2, Q, that is 1.6 10 power 7 the whole square, divided by R square, separated by a distance of 1 meter, 1. So electrostatic force 9 into 1.6 the whole square is 2.56. 10 power 14 plus 9 is 10 power 23. This is the force. 23.04 into 10 power 23 Newton. Calculate the weight For a person of mass 60 kilogram, that is another subdivision, W is equal to M into G. M is 60, G is 9.8. 0 you multiply here, it will become 98. 588 Newton. W is equal to 588 Newton. Okay, fine. Therefore, compare Fe by Fw. 23.04 into 10 power 23 by 588. It is a ratio, so no value, no unit. 3.9 into 10 power 21. When you simplify, you are getting 3.9 into 10 power 21. Okay, this is second problem based on Coulomb's inverse square law of electrostatics. Then you have to compare the Coulomb's force with its own weight. Fe by W we have to calculate. Next, third one. 5 identical charges Q are placed equidistant on a semicircle as shown. Another charge Q is kept at the center of the circle of radius R. Calculate the electrostatic force experienced by the charge. Third one. Charge at the center. Equivalent to a semicircle. 1, 2, 3, 4, 5 charges are placed in a semicircle. Q. Q. Here also Q. Five charges. Definitely between these two charge directions of force, both are positive. So repulsive force, F1. Similarly here, F2. Here, F3. Here, F4. And here, F5. Capital Q and small q, product of the two charges is same for all. That means here F1 and F5 are equal and opposite. Hence they cancel. F2 other side, F4 other side. This is 45 degree, this is 45. F4, F2. So you can resolve F2 and F4 into two components by resolution of a vector. So along the direction F2 cos 45, along this direction F2 sin 45. Similarly for F4, along the direction F4 cos 45, perpendicular direction F4 sin 45. F3, opposite also F3. So right hand side, positive x-axis alone, you are getting the resultant here. Resultant force only you have to calculate. F4 will be F3 plus F2 cos 45 plus F4 cos 45. Here force is K capital Q small q by R square. Capital R. Radius is R. So KQQ by R square. Every force. F2 KQQ by R square. Cos 45 is 1 by root 2 plus F4, that is also KQQ by R square, cos 45 1 by root 2. Fr is equal to KQQ by R square, you take it common, 1 plus 1 by root 2 plus 1 by root 2, 2 by root 2. 2 by root 2 is nothing but root 2. In vector form, I want to write, sir. No problem. You can write I cap. This is the resultant force. Positive x-axis, so we have put I cap. Okay. Next. Suppose a charge Q on S and another charge plus Q placed on the surface of moon. One charge placed on Earth's surface, another charge is placed on the surface of the moon. Calculate the value of Q required to balance the gravitational attraction between Earth and moon. Gravitational attraction, it should be balanced. That is a question. One body is Earth, another body is moon. So Newton's law of gravitation only, Fg is equal to Gmm by R square. Electrostatic force K QE Q1 Q2 by R square. Both the bodies same charge plus Q, that is a question. So here Q1 is equal to Q2 is equal to Q. So I can write F is equal to KQ square by R square. Equate this to G ME MM by R square is equal to KQ square by R square. R square get cancelled. K is 9 into 10 power 9. So Q square will be G 6.6 into 10 power minus 11. Mass of the Earth. Earth mass is 5.9 into 10 power 24. Moon is 7.2 into 10 power 22. GMEMM by K. K is 9 into 10 power. Q I need. So Q will be root of 6.6 into 5.9 into 7.2 by 9. 10 power minus 11. 10 power 24, 22 is 46. Minus 11 means 35. Then this will become minus 9 here. 46 minus 11, 10 power 35. This 9 will go to numerator as minus 9. So 10 power 26. Rearrange all the values 6.6, 5.9 into 7.2. Simplify Take square root. You are getting answer 5.87 into 10 power 13. Extraordinarily high value. 10 power 13 coulomb. Practically speaking, this is absurd. It will never happen at all. Because 1 coulomb of charge means 9 into 10 power 9 Newton. What is Coulomb's inverse square law? Fe is equal to K Q1 Q2 by R square. Q1 1 coulomb, Q2 1 coulomb, or 1 meter. Then K alone will get the answer, that is 9 into 10 power 9. Left hand side forces, so unit is Newton. 1 coulomb of charge. This is the force. 10 power 13 coulomb of charge and all, absolutely impossible. Absolutely impossible. You may get the answer, but it has got no correlation with the basic idea of electrostatics. Okay, next problem. Calculate the electrostatic force and gravitational force between proton and electron. All the data are given. Electrostatic force and gravitational force you have to calculate. Magnitude of electron and proton given. Magnitude, that means mass of both proton and electron given. What's the problem? Fe is equal to KQE, KQP by R square. Charger. What is the value of charge? Electron charge, proton charge, both are same. Separated by a distance of 5.3 into 10 power minus 11. 9 into 10 power 9. QE, QP both are electron. Charge of an electron, charge of a proton. Magnitude wise same. Electron means minus sign will come here, that's all. Whole square. By distance square. Distance is 5.3 into 10 power minus 11. Simplify 10 power first. 9 into 1.6 square divided by 5.3. 10 power 9 minus 19 is 10 power 10. This minus 11 will go as 10 power plus 11. So 10 power plus 21. So this is normal force. Answer 8.2 into 10 power minus 8 Newton. 8.2 into 10 power. So this is minus 38. Minus 38 plus 9. 10 power minus 29 plus 11. 10 power minus 18. Here also R square. Minus 11 the whole square is minus 22. Numerator plus 22. 10 power minus 38. 10 power 32 plus 9. 41. 41 minus something. So calculate that value of force. That is 8.2 into 10 power minus 8 Newton. Similarly, you have to calculate gravitational force. G, mass of the earth, mass of the moon by R square. 6.6 into 10 power minus 11. Electron mass 9.1 10 power minus 31. Mass of the proton 1.67 into 10 power minus 27. Simplify. Separated by a distance 5.3 into 10 power minus 11. So this is gravitational force of attraction between proton and neutron, proton and electron. 2.41 into 10 power 39. See here, electrostatic force is 8.2 10 power minus 8. Gravitational force 2.41 10 power plus 39. No, it is 3.4 10 power minus 47. 3.4 10 power minus 47. So when you compare Fg by Fe, 3.4 10 power minus 47 by 8.2 into 10 power minus 6. That you compare, that answer only we are getting nearly 10 power 39. So Fg is equal to 10 power 39 times of Fe. Okay, so this is fifth problem. Sixth one. A spark plug in a bike or a car is used to ignite the air fuel mixture in the engine. It consists of two electrodes separated by a gap of around 0.6 millimeter. To create the spark, an electric field of magnitude 3 into 10 power 6 volts per meter is required. You have to calculate one potential difference to produce the spark. Second, if the gap is increased as a potential difference increase or decrease or remains the same. Third, find the potential difference if the gap is 1 millimeter. General formula for electric field versus potential is E is equal to minus dV by dr. Potential gradient is electric field. That is in magnitude B is equal to E into D or E into R. That's okay. Electric field is 3 into 10 power 6. Distance is 0.6 millimeter. So 3 into 0.6 is 1.8. 10 power 6, 10 power minus 3 is 10 power plus 3. 1800 volt. 1800 volt. Second, if the distance between the plate is increased, what happened to the potential difference? Here, V proportional to D. Potential difference and the distance of separation, it is directly proportional. So I can write potential difference increases. Third, what is the potential difference if the gap is 1 millimeter? So V dash is equal to E into D dash. Electric field is constant. plate distance is changed. So E is 3 into 10 power 6 D dash 1 millimeter 1 into 10 power minus 3 3 into 10 power 3. So that should be 3000 volt. Correct? So this is the sixth problem. Seventh one. A point charge of 10 microcoulomb is placed at a distance of 20 centimeter from another identical point charge of plus 10 microcoulomb. A point charge of 2 microcoulomb is moved from A to B as shown. Calculate the change in potential energy of the system. Interpret your result. Two charges. Third charge. This is 5 centimeter, 15 centimeter. This is R1. This is R2. R1 dash. R2 dash. 10 microcoulomb. 10 microcoulomb. Minus 2 microcoulomb. When it is moved from here to here, same. Now you calculate potential energy between these two. Add. Before moving the charge, you calculate potential energy. Potential energy U is equal to Q1 Q2 by 4 pi epsilon naught R. 1 by 4 pi epsilon naught as usual 9 into 10 power 9. Q1, Q2 both are 10 microcoulomb, 10 into 10 power minus 6 the whole square. Divided by R. There, this is R1, initial potential energy. Q1, Q2 by 4 pi epsilon naught R2. R1 is 5 centimeter. Similarly, here 9 into 10 power 9. Q1, Q2 between these two and between these two. What are the charges? 10 into 10 power minus 6. 2 into 10 power minus 6. Whole divided by. What is the distance, ma? 15 centimeter. Of course, you can take these two common. What? 1 by 4 pi epsilon naught 9 into 10 power 9, we can take it out common. So remaining, simplify 10 into 10 power minus 6 the whole square by 5 into 10 power minus 2. Similarly, 10 into 10 power minus 6 into 2 into 10 power minus 6. Simplify this, calculate, add, you have to add. When you add, the value of initial potential energy is minus 4.8 joules. Why minus means here one charge positive, one charge negative. So minus sign will come. Final potential energy UF Q1 Q2 by 4 pi epsilon naught R1 dash Q1 Q2 by 4 pi epsilon naught R2 R2 dash. 1 by 4 pi epsilon naught 9 into 10 power 9. R1 dash, R2 dash, we have to calculate. How will you calculate that? R1 dash is equal to this square plus this square. What is that value? R1 dash. How to calculate R1 dash? 5 centimeter only it is moved. This is 5 centimeter. This is also 5 centimeter. So root of 5 square plus 5 square, 25 root 2. 5 root 2 centimeter. Similarly, we have to calculate R2. What is R2? R2 dash will be 15 square plus 5 square, 225. 225 plus 25, 250. Root 25, root 10. 5 root 10. 5 root 10. R1 dash, R2 dash. You substitute 1 by 4 pi epsilon naught Q1, Q2, 10 into 10 power minus 6. Next, Q2 minus 2 into 10 power minus 6. What else? Denominator R1 dash, R2 dash. So you can take it common. 10 power minus 2. 1 by R1 dash plus 1 by R2 dash. 1 by R1 dash is what? 1 by R1 dash. 5 root 2. 1 by 5 root 10. Rearrange. Simplify. You are getting the answer minus 3.683. Correct? So initial potential energy minus 4.8. Final potential energy minus 3.683. Therefore, change in potential energy. What? Final plus y plus minus of minus plus 4.8. So the final answer is 1.117 joules. 1.117 joules. Next problem, 8th one. Here we have 3 or 4 subdivisions. Calculate the resultant capacitances for each of the following combinations of capacitors. Before going into the problem, we should know the basic formula when capacitors connected in parallel, when capacitors connected in series. Capacitors in parallel. C, C1, C2, C3. Q is equal to CV. Basic formula. C is equal to Q by V. In parallel connection, starting and ending point is same. So potential is constant. Charge is different. So Q1 is equal to C1V, Q2 is equal to C2V, Q3 is equal to C3V. So therefore, total charge is Q1 plus Q2 plus Q3. So I can take it out V common as C1 plus C2 plus C3. Then together when you connect the resultant or effective capacitance, that charge is also Q. That formula is Cp into V, where Cp is the resultant capacitance when connected in parallel. Compare these two, you will get Cp is equal to C1 plus C2 plus C3. When capacitors connected in series, current charge flowing through the capacitors is constant. The potential what you are giving will be divided here. V1, V2, V3. So, charge flowing through will be same. In series connection, charge or current is same. In parallel connection, potential difference is same. Basic common. So, V is equal to V1 plus V2 plus V3. V is equal to V1 Q by C1, Q by C2, Q by C3, Q into 1 by C1 plus 1 by C2 plus 1 by C3. Another formula Q by CS. Another formula Q by CS. Another formula V is equal to Q by CS. So this is equation 1, equation 2. V is equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3. Together when you connect, the resultant will be V is equal to Q by CS. Implies Q by CS is equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3. Cancels. 1 by CS is 1 by C1 plus 1 by C2 plus 1 by. So the resultant capacitance inverse of that one will be 1 by C1 plus 1 by C2 plus 1 by C3. Parallel connection resultant will be C1 plus C2 plus C3. Series connection 1 by CS is reciprocal of the individual capacitors. So CS will be inverse. So we can take some examples and then do it. First one capacitor C0 connected in parallel with another two C0. C0 in parallel, together connected in series with the C0. First we'll finish off this. C0 and C0, they are parallel. So I can write C1 plus C2. So it will be 2C0. Then this C0 and this 2C0 will be in series. Implies 1 by CS is equal to 1 by C0 plus 1 by 2C0. 2C0 is common, 2 plus 1. 3 by 2 C0. So CS, most of the students, they are committing a mistake here. After finishing the answer, they are leaving it as it is. No, because you are calculating 1 by CS. We need to calculate CS value. So CS will be 2C0 by 3. Correct? Fine. Second, Two capacitors parallel. Another two capacitors parallel. C naught, C naught, C naught, C naught. First, you calculate these two. CP1. These two are parallel. CP1 is equal to C naught plus C naught, 2 C naught. These two are parallel. CP2 is equal to C naught plus C naught, 2 C naught. Now these two in series. CP1, CP2 are in series. So I can write 1 by CS is equal to 1 by CP1 plus 1 by CP2. 1 by CP1, 1 by 2 C naught plus 1 by 2 C naught. 1 by 2 C naught plus 1 by 2 C naught means what? 1 by C naught. That is CS is equal to C. Same problem. CS is equal to C naught. Third, two capacitors C naught, C naught across the diagonal 1 C naught. Simple. C naught, C naught, C naught. Parallel, all are parallel. If you want these two C naught, side one C naught. Anything you can do. Cp is equal to C naught plus C naught, 2 C naught. That 2 C naught is connected in parallel with another C naught. So directly you can write 3 C naught. Straight. Okay. Some problems might be complicated. Slight. Current electricity is similar to that. We are going to show resistors using Kirchhoff's law, Ohm's law. Now, fourth one. 4 capacitors are connected. C naught, C naught, C naught, C naught. If you put everywhere C naught, then calculation you will get confused. So we will take this as C1, C2, C3, C4. 4 junctions here we have. We will name it PQ, RS. Across PQ we want to calculate. Across PQ. Across PQ means the C1, C3 will be in series. C1, C3, C2, C4. Series connection formula you can write 1 by CS1 is equal to 1 by C1 plus 1 by C3. So C1 plus C3 by C1, C3. CS1 is equal to C1, C3 by C1 plus C3. Similarly, you do for C2 and C4. Similarly, 1 by CS2 is equal to 1 by C2 plus 1 by C4. CS2 will be similar to this. So I can write C2, C4 by C2 plus C4. Now these two are parallel. Equivalent diagram. CS1, CS2. Cp is equal to, simply you add. What is CS1? C1 C3 by C1 plus C3. C2 C4 by C2 plus C4. Add means LCM. Cross multiply C1 C3 into C2 plus C4. Similarly, cross multiply this. Divided by these two. Cross multiply C1 C2 C3 plus C1 C3 C4 plus cross multiply C1 C2 C4 plus C2 C3 C4 divided by C1 plus C3 C2 plus C. Across PQ, when you want to calculate what is the resultant capacitance, this is the value. Same problem across RS. Across RS, I want to calculate, sir. You can calculate. No problem. Across RS. So these two C1 and C2 will be in series. C3 and C4 also in series. This is R. This is C1, C2, C3, C4. In series, 1 by CS1 dash, 1 by C1 plus 1 by C2. CS1 is equal to C1 plus C2 by C1. C1 C2 by C1 plus. Similarly, these two, 1 by CS2 dash, 1 by C3 plus 1 by C4. LCM CS2 dash is C2 C4 by C2 plus C4. Simple. Now, these two are in parallel. So I can write CS1 dash, CS2 dash. CP resultant will be CS1 dash plus CS2 dash. Add. Parallel connection means we have to add. So the value is CS1 dash C1 C2 by C1 plus C2 plus C2 C4 by C2 plus C4. LCM common term C3 C4. This is C3. C1 C2 C3 plus C1 C2 C4 plus C1 C3 C4 plus C2 C3 C4 whole divided by C1 plus C2 C3 plus C. Correct? Like that, innumerable problems we can work out. Basic thing you have to understand. In parallel means you have to add the capacitance. In series means 1 by CS is equal to 1 by C1 plus 1 by C2. Equal means 1 by C plus 1 by C. That's all. So these are the few problems related with electrostatics. Next, we will see current electricity problems. Thank you. We'll continue.